join me in welcoming our speakers on stage. I'd like to welcome Mr. Mathias Vandecasteele from Sweco, Vietnam. I'd also like to welcome Nguyen from G88, Architecture and Urban Planning. And finally, Vasudevan Murugesu, R&D Manager at Sika Limited. And for this session, I will, like Christina, change my hat and be happy to be moderating this. Excellent. So, thank you. So we'll be talking for the next 40 minutes about sustainability in the built environment here in Vietnam. This morning we heard that the built environment is responsible for 40% of the global carbon emissions. That's a pretty heavy number to carry on our shoulders. I worked at not one of the world's largest, but one of Denmark's largest engineering companies, and in Rumble alone, we were responsible for 10 million square meters of space annually. So that's a really, really big number. I'm sure for Sweco, it's even bigger than that. It comes with a big responsibility. So really exciting to be able to discuss with these three gentlemen. What we'll do is I'll just give you a frame. We'll start with what we call 3 lightning energizers. So each panelist will give you 3 minutes of pitch. Then we'll do a quick round of questions and interactions. There might be time for questions. If you want to share through the QR code, you can do that, and we'll try to get to them. And then we'll end with sort of a goodie bag of what can you bring home with you in terms of working with sustainability in the built environment. We all have something we can do. So without further ado, I'd like to start, and perhaps Mathias, you want to start with your energizer.
Okay.
3 minutes.
3 minutes, here we go. Okay. There are 3 statements I would like to make to start off. First, as an engineer, everybody always expects me to talk about technology. What kind of technologies are there? My first statement is we first need to make trying buildings better before we apply technology. We saw it in the presentation earlier of Bruno, of Deep Sea. With some nature-based solutions, you can already do a lot. It's the same in the built environment. With just the selection of the plot, with the orientation of how you put the building, sometimes you can already save 20% of the energy. So that's the first message I would like to give. With what you save there, actually, that saves, and that brings me to the second. You save actually already a lot of energy like that. That means that you also don't need to invest capex in those machines, in that equipment, and that saves you CO2. So CO2 reduction for me, and that's the second point, CO2 reductions means also a cost reductions until a certain point, and this is very important, I think, certainly in the context of Vietnam, that we look for that tipping point, like where do we have those savings that actually also bring capex, opex savings, and where is that tipping point where it starts? Of course, if you go very ambitious, it starts to become more expensive again. And as a last point is also related with that CO2. We are always talking about built environment. I'm sure everybody who reads this topic on the board thinks a new building. We should start looking more at the existing buildings we have. The new build market, I don't know what it represents in Vietnam, but it's a small percentage. What we have, the building stock we have in District 1 and in the center of the cities is huge, and there's a huge potential to save there. And that CO2 that is already there, we don't need to spend it.
Thank you. Super good point. I'll turn the mic over to you, Tan, for the architecture point of view.
Thank you very much. So we are G88. It's an architect company that founded in Switzerland in 2000, and now with 15 years working in Vietnam. And I really agree with what Mathias says, we need to focus on the very simple solution first before applying all kind of technology on top of it. And I think because of our Swiss root, so in the very beginning, we are caring deeply about the context, so meaning the people, the bioenvironment, the climate, etc. And this helped us to tackle the question of sustainability in very early stage. And our experience in working in Vietnam can be, in terms of sustainability, can be summarized in maybe 4 key strategies. The first one is flexibility. We need to create buildings that are flexible enough that can adopt future change from the clients or from the operation. The second one is we need to provide passive design in terms of nature ventilation, nature lighting, sun shading to create different buildings that have high energy efficient during operation. The third one is building for adaptation, meaning that the building can be able to evolve or can anticipate future change in terms of environment around it. Because as we know, Vietnam is growing very fast. So the context that the building we build now maybe can change maybe 1 year or 2 years. So this kind of anticipation for us is very important to make sure that the buildings can stay long, can last long, and don't need to tear down and build the new buildings. And the last point we have is focus on the robust and simple design, meaning that prioritize the local construction method or local material, so you don't need to import materials or have a kind of complexity in terms of construction. So yeah, this is what we are doing here, and we are, let's say, we are looking forward to work with engineers or material to continue this path.
Thank you. So we heard from the engineer, we heard from the architect. I'd like also to hear from you, Vasu. You actually provide sustainable solutions on site. So for your energizer.
Thank you. I am from Sika. So it's we have been in the worldwide from Swiss, it's a Swiss company for 115 years, and in Vietnam we are also for 30 years. We are providing all the solutions for sustainability and also in the construction as a material supplier. So the main is the CO2 emissions, which we were talking about maybe in the scope 3, which we are talking about. Scope 1 and 2 is more on the energy design. The architects are doing a lot to save the energy in the designing. But as Sika, we are doing it to reduce the cement content. So cement is the big polluter. It's like we have 100 kilo of cement, so it's about 70 to 80 kilo of CO2 emissions to produce this as an OPC cement. Yeah. But so we are looking at SCM material, which also a resource. So one is reduce the carbon content of the construction material in the project or in a high-rise building, and also using some waste. So this is second one is the resource utilization. Yeah, we are using them recycle or a circularity, using some waste from like some thermal power plants or steel factories like a slag, fly ash, and many of these items as a sustainable replacement material for cement. So this helps us reduce the CO2 emission in the first one. Yeah. So that's the key. We are cutting down the emissions in the scope 3 a lot. And in our materials also, we are walking the talk. Sika is doing in-house, like we have a target also, like Vietnam. 2050 is the net zero target for Sika. And we have committed, and we have this science-based target initiative, and following this World Business Council of Sustainable Development from Switzerland. So it's very transparent, and we have the figures. We contributing to that. And the second part also, to enable the savings of architects' designs. See, Sika, we have products for roofing. We have some reflecting roof membranes. So this reduces the energy in the building, which will contribute to saving the energy of air condition or whatever in our countries. So all the roofs are reflected. And number 3 is also, we have products for to increase the life, like the life of the building is very important. So with the durable solutions, we can increase the life cycle of the building. So there are some materials, like we were hearing also at the beginning, where Kone were using some carbon fiber replacements. So we have also product in Vietnam. Practically, we have used to strengthen some bridges on the way to Mekong Delta. So there are some Carboduo fibers and also CFRP. So these materials can, if there is a structurally weak, we don't need to demolish the building, but we can put them with this strengthening. So Sika has these strengthening solutions which can increase the life of those buildings.
Excellent. Thank you. I have a question for you, Tan. Can you describe a project where sustainability fundamentally changed your design approach?
Thank you. I think the very good example I can give is actually one of the factory in Bingzung, so not so far from here. It's called Jacob Steel Company. So this is a Swiss company that producing stainless steel cable in Vietnam. So I think most of us, when we think about industry building, we think about the large building with a large roof that fully run in by air conditioner. And on this case, we, with Rolly Makini, which is our Swiss partner, we decide to challenge this kind of typology. So we able to, let's say, use a different sustainable strategy to change the typology of the buildings. So instead of doing a large roof, we working with the client to save as much land as possible, reduce maximum the building footprint, stack the production hall on top of each other. So we keep land for community, for workers, but also keep the land porous for soil, for water. This is the first, let's say, strategy. The second one is, as we go higher, we're able to catch more wind. So like Mathias said, with the orientation of the building, we catch more wind, and we also come back to the client and say, how about we run the factory 100%, not 100%, but 50% natural ventilated. So we work with them, and we found the good operation method with the Jacob team. So from 10 a.m. to 4 p.m., the factory is closed with AC, because there is certain product that need certain requirement. But from 4 p.m. to 10 p.m. the next day, the factory is completely open. On the facade is open, allow the wind come in, cool down naturally the factory, and also push down on the dust that produce along the operational. So this is the second one. The third one is we move on the internal circulation of the production hall outside to have the two corridors run along the building that act as a shading for the factory. So with all of this strategy come together, we're able to save 30% of the energy of the factory compared to the same or similar size factory in nearby. Plus, and then we have PV panel on the roof that save another, I think, 40% more. So with that, when the architect and the clients that is willing to work together towards sustainability, there is many solutions that help to change the building type, or to make the building type more efficient, and more sustainable.
Excellent. And tying on to that, for you, Mathias, can you tell us about a time where engineering innovation made a building significantly more sustainable or energy efficient?
Sure.
Perhaps a little bit about the process of moving to that.
I think before I jumped in a bit too fast, for people who didn't get it, I'm with Sweco. Sweco is a Swedish engineering company. We have 22,000 people around the globe, and we've been in Vietnam for 13 years. So.
Thank you.
To that. Now, to come to your question about innovation that we use, to pick in a little bit of what we said before, I will pick out a design innovation, because what I see, what gives us a big change or gives us a lot of possibilities to design sustainable, is that we work with BIM models, so that we actually put the project in 3D, that we can visualize it. So what does that allow us to do? What does it allow us to do is to take the building before it's built and go through it 365 days through the whole year and see how will this building actually react to the climate in Vietnam, to the climate here in Saigon. So what Dan was just saying about natural ventilation, like that, with the model, without a 3D model, we cannot quantify it, we cannot calculate it. We cannot calculate, for example, that in this case you save 40% of energy. So this allows us to see, like, okay, if we open that window so much, or if we change the glass from this type to this type, how much energy will we save? So this is a quantifiable tool that we can also use to go in a conversation with the investor or with the client. A second thing, a next step, because that I call always BIM is like level 1, then you have, if you do simulations, that's level 2. Level 3 is actually when you start using it in the design. For example, when we do a hospital, we use it as a virtual reality tool. Like we go through the hospital and see where are the bottlenecks, how are the flows, how are the elevators working? So that's the next step, like how will the building work? And then the next step, and that's something I hope we will see in 5 to 10 years, everybody talks about AI. What will AI bring for buildings? I think that's the next step. So we have the 3D model. We actually will make a twin of the building. You will have the real building, and you will have the twin, the digital twin, like they call it. And that we can use to, for the more data we have, if there's one thing that AI likes, it's a lot of data. So out of that building, we will have a lot of data inputs, like how does the building react on a Tuesday? How many people come to the office? How occupied is a meeting room? If you start collecting that data day after day through the years and then use AI, we have done a first pilot project in Luxembourg, and we see that on a green building, on a very cutting-edge, high-end green building, we could save an additional 40%. So that's for the future.
Absolutely. Thank you for that, and thank you for sharing some of the tools that actually enable decarbonization. For you, Vasu, I was hoping that you would like to share a story where you had to innovate on site to meet a client's sustainability goal. What did you do differently? What did you change on site? And what was the impact?
We can say as also again in the concrete carbon emissions. So our one of the concrete producer or precast producers, like we work with many of them in Ho Chi Minh City and also in Hanoi. So they have to use this HCM material, which I said as a sustainability, it will reduce the CO2 footprint. Like if they go with the normal concrete, same amount of cement, it may have about a 300 to 400 kilo of CO2 for a cubic meter. But they wanted to use 40% of this replaced with some HCM materials. So the issue with the HCM material, when you're using it, we have two challenges. One challenge is to make the workability similar to that one, which this material is different to with the cement. And also the early strength. Sometimes the precasters want to produce and go with the turnover as quick as possible. And we have 1 day compressive strengths. They are looking at 40, 50 MPa, megapascal in a day. So these things are two challenges, which with the normal cement, they can achieve easily with the existing design. So they were asking us to provide solutions with the 40% replacement. So our concrete R&D team, we work with them, and we start doing a lot of designs, like pre-trials, and we check every cubes, like about random, how much is the cylinder strength we get in 1 day. So as we get this compressive strength and the workability, this takes a lot of work. So we did first in the laboratory, in the Sika lab, to achieve these things in our conditions. And then we had to make this new product which enables the reduction of this cement content. So then we have to make another 1,000 ton as a 1,000 kg as a pilot and go to the customer and then do the trials with them. So this is like enabling our customer to save and CO2 emissions in a sustainable way. And then we had to work with them. They produce a few piles, like it goes fail and pass, and then we achieve the workability plus the strength, and they can remove the piles to the production. So these are used in the foundation of buildings. Like we just see only a 20-story building, but nobody see underneath what is it. So there are many bore piles, like it's a huge volume of concrete under the buildings. So those foundation, like the two types, the one on the bore pile, which may go down about 60, 70 meters also, with a 1 meter diameter, and it'll fill with the concrete. So here also they're looking for some materials with replacements. So we have to develop something meeting the floor requirements and also the hardened concrete and the wet concrete requirements. So this is what the challenge, and we achieve working with them and then enable them to contribute to the sustainability of the people. Yeah.
Excellent. Thank you for sharing that. And hopefully other clients could benefit from that test and trial and error method as well. I've been checking the questions. We don't have so many questions online. So that means that we can actually have good time for the final questions and for key takeaways that we hope you will bring home with you to whatever you do in your daily life. And that it can trigger continued acceleration of sustainability in the area that each of you work on. So I'd like to start with you, Tan. How is sustainability changing architecture?
Thank you very much. I think what we are, I think sustainability now is a must that all the architects need to have this in mind to move forward. And what we are working now is how to, let's say we change the question how to be more sustainable. So we, like you said, in construction industry responsible to 40% of carbon emission, we can save the construction carbon by reusing the existing building, like Mathias mentioned. We can optimize the operation carbon by higher equipment, better equipment that can get income in the future. But this has some kind of limit. And what we are working on is maybe try to question how we can overcome this limit by asking the question is what is a comfort level in architecture. So we are working, we are in discussion with Transolar, which is a German, very well-known climate engineer, about this question. I give you a very simple example. We are in this room with, I think, the air conditioner target 24 degrees, which costs a certain amount of energy. But if we just add some ceiling fan which run a very slow speed at maybe 1 meter per second, the temperature in this room can push a bit higher to 26. And this 2 degrees is meaning a lot of energy. So there is this kind of question: what is really with the comfort that we need as a human being in a certain space can help to tackle and pushing this the saving of the energy in different sectors.
Thank you for that. And I'd like to turn to you, Vasu. What's the most surprising benefit you've seen from a sustainable building project? Something that perhaps moved us from short-term to long-term.
Okay, like in the morning we were talking also with the financials about sometimes the sustainability have the cost more, but in the concrete and also in certain fields, we can say a savings. It will be a benefit to the owner. Like what I said is resources circularity. If they are going to use a material like which is a waste from there, like this will reduce the cubic meter cost for the concrete RMC producer or the precast producer or for the project, which is an additional benefit, which is a sustainability, but it also cost savings for the owners in the construction industry. Yeah. So this is one point which is key about the finance. And the second one is also nowadays there should be a benefit from this. We have many green building certificate. We were showing something of a lead. So there are some contributions and the points are now calculated for many projects. Like you finish a building projects, do you have a certificate? Because if you don't have that, or certain points contribute. Like from the construction side, we do have like there are certain credits. Like we have a very critical, like on a flooring product, we have a VOC certificates there is, then also resources, how we're coming. So there are certain credits in LEED or VGBC or EDGE or any kind of this green building councils. They have certain points and credits. So which will be one of the benefit for the owner or the client, and then the contractors who is buying these sustainable products or sustainable solutions, they will earn these credits better than others. So that project who is doing maybe an example of a Kotikon or Habain or whoever, they can earn this project, and this is owners certified as a LEED Platinum or LEED Gold. So this is the additional benefit which they should look for this. Sika also, we work with the architects and specifiers to propose these solutions, which is having already a green certificates or green building certificate, which is certified, and they can contribute some credits to them. Yeah, and then we also have to back up this as a EPD, LCA, or a PCF, product carbon footprints, we can provide if that case comes. So this is an additional benefit to the owners. It can be a cost benefit plus this additional getting this certificate. So they should go for these sustainable solutions. And this is all our requirement, and which is the world is looking at. Thank you.
Excellent. And before I turn to you, Mathias, there is a question from the audience for you. You mentioned sustainable replacement materials. Do you also consider how these replacement materials are socially sustainable as well?
Yeah, we do have these materials. So every materials, there is, we call a Sphera cloud. There is emission calculations of each material. So this is a responsibility of the producer or who is having the waste. So then they need to have a checking of this material is how much emissions. So it's a worldwide. There is a Sphera cloud, which is a base. You can calculate the figures for each of them. Like it's a slack means how much is the carbon footprint or global warming potential of this material, which is compared to cement is much lower. So this is very clear in our calculations, but we can also justify that with this. But if the local companies are not clearly giving what is that, so it may be a questionable, so we need to see that correct one. But in the worldwide reference figures of certain materials, so we have clearly, there is a reduction in the CO2 emissions. So we can use that, yeah.
Thank you. And I'd like to turn to you, Mathias, for a good final question. And what's one myth about sustainable building in Vietnam that you want to bust?
Yeah.
The floor is yours.
I like that question. One myth, actually, it's a challenge of what most people think. Try to imagine if you think like, what is the most sustainable building you have in mind in Vietnam? I'm pretty sure everybody thinks on the latest green building, net zero building, whatever we talk a lot about. But basically, the most sustainable building is the building you don't need to build. And that means like I started with, is the buildings that we have. If we do a renovation, then actually we save much more CO2 than starting over from zero. There was a study from, I don't know if it was Denmark or Sweden, but that said, like, if you build the latest green building, net zero building, or you have a building, normal building here, you change the glazing, you refurbish the HVAC, the cooling equipment, it takes 45 years before that green building offsets the CO2 of a simple renovation. So 45 years, I don't know how many investors are thinking when they are constructing a building, when they are or when we are designing a building, how long are we thinking about for using this building? But it's a long time. And we have a lot of buildings here in Vietnam. And I think of three things. You have a lot of companies who came here 15 years ago, 20 years ago. They have existing office buildings that need a refurbishment, or hotels that want to go from a certain brand to another brand, rebranding. But also, everywhere we see, everybody knows this kind of project where the structure is there, and then it stopped because the investor came into trouble. And it's a very challenging thing to have for other investors to buy that structure. An existing structure, it's not so easy. But the technology is there, and with what I said before of making 3D models, visualizing everything, it's possible. And actually, that embedded CO2 is already there. It's a saving before you even start. So that would be the myth I would like to bust today.
Thank you so much, and thank you to all three of you for sharing perspectives on sustainability in the built environment. It's a difficult journey, but we start by talking about it and by raising ambitions, so thank you for doing that. Please allow me to give the panel a really big and warm hand. And I'd like to invite Stella Sevegren to come to present a gesture of appreciation to our speakers.